Hello, this is Laurent Johan, and today I'm going to be presenting my Project 1 for IA370, which is manufacturing in a Martian base. So let's get started. So here's a quick introduction to what we have going on here. So my team of engineers has decided to implement some manufacturing systems in Mars in order to have the proper amount of resources, tools, and things we need to explore the planet and potentially inhabit it in the future. Manufacturing on Mars is not easy, implementing systems is not easy, but thanks to the technology and knowledge that we have at our disposal, we were able to adapt in order to build things like, a sustainable water supply. Water is very important. A plant system that does not require soil. Building blocks that are made from regolith, material that is found a lot in Mars, and much more. Regolith was actually the MVP of this project, as it has a lot of uses that I'll highlight later on. But yeah, this is what we learned from our studies, and let's get started. The first system that we decided to implement on Mars was our flow shop. And in order to do so, we needed to choose a critical product to begin with. We had a very long list of candidates, but we decided that a very essential thing was food and plants. And because of this, we decided to focus on implementing hydroponic pods. Hydroponic pods are used to grow plants without the use of soil or sunlight, which, as we know, are very scarce in Mars. That rhymed. Instead, they use minerals combined with water and light that replaces the use of sunlight. But in order to do this, we need to find the replacement for soil. So, to use these hydroponic pods, we need a growing medium, which in this case would be regolith, as I mentioned before. It's a blanket of loose minerals and rocks, which will be used to stand in for the soil. So here are the schematics for our flow shop. As you can see, we first start with the regolith, which then goes through a process of separation, since regolith has very big stones that make it more difficult in order for it to go through the full process. This separated regolith will go through a cleaning process and then to the heating process. When regolith is heated, it can either go three ways. It can either give us trapped water inside the regolith. It can become residual material that we can't use, that it may have other uses, or it will become the usable regolith that we will use in our plant pods. The trapped water that came from that regolith can also be used. We can filter it, then we can clean it, and we can use it for the cleaning process in the separation of regolith, which is kind of makes everything go round to make a smooth and continuous process. Then that water and the usable regolith can be put into the plant pods in order for them to grow. Just by looking at this system, we believe it's an extraction system, as we aim to create a continuous process that provides us with clean regolith powder constantly. Although extraction systems are usually seen in large factories, and they have a lot of chemicals and stuff, we don't believe this is going to be too large. As you can see, the process is not very long. Also, extraction systems are known to be continuous, and there are some things we might run into, which can be maybe not having enough regolith or the limited plant pods we have being full. But we believe this process can be very efficient and very reliable. So the next system we decided to implement in Mars was our job shop. We were thinking of our critical product for our job shop, but honestly, job shops are focused on creating a large variety of items instead of a focused one. And our focus here was to make these large variety of things, but with reused materials, as we want to be sustainable on Mars. We don't have too much materials to work with, so we want to be as, we want to recycle as much as possible. This is an example of a low volume, high variety system. And we also need to measure stiffness and toughness of our materials in order to see if they're good and usable. Here are the schematics for our job shop. We have a resource pool, which is the regolith we mentioned before, the residual material from the regolith, and also things like plastics, glass, and aluminum. Many more things can be used, obviously. For our job shop, we can focus on many things. We can focus on lathing our materials, turning it into cylinders to be then either milled, drilled, bended, welded. We can do many things with this. We can take many different steps. Maybe we can lath our material, then mill it, and then drill it to get fuel and soil. Maybe we can lathe it to then wield it, and then assembly for building blocks, cement, and robotic parts. And maybe we can lathe it, mill it, drill it to weld it, and then for it to become hand tools and materials. So it really depends on what we want to make at the moment. Job shops are very adaptable, so it's what we really want to make in the moment, the things we need. If we want to build stuff, we will make building blocks, and we will focus on certain areas to get that. So yeah, this would be our job shop schematic. So after creating our materials in our job shop, we have to conduct tensile tests in order to see if these materials are useful. So we know the steps of conducting a tensile test. We first select the material, then we cut it in order to create the tensile. We will handle it and then place it in order to test it and pull it into it until it fails. So the two things we have to focus on are stiffness, which is the resistance of a material to deformation under a load, and we can calculate a material's stiffness by looking at the Young modulus, which is basically the rise over the run. We also have to look at the higher Young's modulus, the more stress is needed to create the same strain on that material. Just an afterthought. We also need to calculate toughness. And toughness is the ability of a material to absorb energy and deform with no fracturing. And in order to find the toughness of a material, we have to calculate the area under the stress strain curve. And it will be depicted and measured in joules per cubic meter. Personally, I would, create, like I told you, the material and then use what we made in order to conduct these tests. As you can see in the chart here, the brittle material has a complete different curve as the ductile material. In this case, the brittle material will be something like recycled plastic, and the ductile material will be something like iron for tools and robotic parts. So our next system that we decided to implement in Mars was the project shop, and our critical product here is a rover repair station. In this system, we will create a project shop in order to successfully run a rover repair station. The shop involves many different phases, from resource pools to dismantling to repairing to molding and fixing, until we assemble, new rovers, maybe new parts for the rovers to work, because we always need them to keep on working. Rovers are important to extract data and to explore Mars, so they're very valuable to us, and yeah, we need them to work constantly. So here are the schematics for our project shop. As you can see, we have a resource pool that focuses mostly on damaged rover parts and minerals and materials that can be used to build these other parts or fix these other parts. So we will have to allocate these resources depending on what we want to do. We could either dismantle the rover, then repair it, then assemble it until we get it done. We can dismantle parts, mold them, rebuild them for other uses, and then assemble them to create another rover. It really depends on what we have to do at the moment, but we just want to keep pushing these rovers out so they work properly and they help us in our expedition in this planet. So here is the fourth and final system that we have implemented in Mars, and it's a lean manufacturing system. So our critical product in this case for lean manufacturing was regolith building blocks, which is a very specific thing that we'll go into later on. It's one of the characteristics of lean manufacturing. As I've mentioned before, regolith has many uses and has been crucial in the implementation of our manufacturing systems in Mars. And the only issue I can think of right now is that although lean manufacturing focuses on being efficient, I do believe our MS is very simple, and we believe more steps should be taken in order to make this regolith even more usable when it becomes building blocks. So here are the schematics for our lean manufacturing system. As you can see, the regolith is also obtained, it's also separated, then it's put into a production line, which makes the regolith into smaller pieces, is passed through a furnace, which obviously releases smoke. That's a drawback right there. From this furnace, we can get residuals. They have other uses later on. We can add alloys and composites in order to combine with the residual goods that we get from the regolith, we press them, and then we get our building blocks that are very essential to what we want to do in Mars. As I mentioned before, lean manufacturing is focused on reducing waste and being efficient. Honestly, this is a very quick system. It's very linear, and it reduces a lot of waste. The only thing we would have as waste are residuals, which is not even considered waste because we can use it for other things. The only drawbacks of this lean manufacturing system is that it must be overlooked constantly. Everyone has to kind of keep check on it for it to run smoothly, and it has little to no flexibility. We are only focused on making these blocks, and if we ever need another system to make something else, it would be hard for this lean manufacturing system to kind of adapt. It would need a lot of updates and a lot of installations and things like that in order to do other tasks. But for what it's made for, it's very good. And now to the conclusion. After implementing all these things in Mars and seeing how they work, it really was no easy task, but thanks to the variety of types and practices of manufacturing, we were able to come up with many different solutions using many different resources and many different practices. Manufacturing system will only become more reliable and efficient as time passes, and hopefully these become so good that we will actually be able to live in Mars and hopefully in other planets we explore in the future. So thank you for your attention and have a good night.